Okay, now we'll try to identify the components which you will find in the cockpit. In other words, the controls you need to know when it comes to air conditioning system of Airbus A320 family. First of all, I'll briefly or quickly go through each and every panel and introduce you the push buttons and rotary switch. Then I'll describe the function of each and every push button and the controller. Okay, first of all, we have the air conditioning panel, the overhead panel which I showed you. So there you will find several rotary selectors and several push buttons. So first of all, we have the pack flow selector which has 3 positions: low, normal and high. So this pack flow selector is applicable when it comes to A319 and A320 aircrafts, but when it comes to A318 you will have a push button which is called with identified with high flow title. So in A318 you have a push button, here it says high flow, and in A321 you have a push button which is identified as econ flow. So I'll explain you later the functions of the push buttons as well as the rotary selector. Then you have 3 rotary selectors. On top of that you have 3 headings which are boxed. So here it says cockpit, forward cabin and aft cabin. So if you can remember, I told you during previous lessons, when it comes to air conditioning system of A320, the air conditioning supply is supplied to 3 zones, and those 3 zones are forward cabin, forward flight deck or the cockpit, then you have the forward cabin, then you have the aft cabin. So these are the 3 zones which the air will be supplied. Below that you have 3 rotary selectors. The function of the rotary selector is mainly to set the required amount of temperature in each and every zone, and you can see here it has mainly you can have several positions, but they have mentioned here the coldest position will be cold and here the hottest position is hot. So I'll explain you the functions later. And here you can see a hot air push button which we discussed in the last lesson. The trim air pressure regulation valve is controlled by this hot air push button. And here you have the pack 1 and pack 2 push button switches to control the pack flow control valve. So and there's another push button which we should know when it comes to air conditioning system. It is this ram air push button. So this push button and this push button and this rotary selector and this push button we'll discuss when it comes to chapter 36 or the pneumatic system. So and you can see that the legends are also indicated in these push buttons. So you will not see both these legends at the same time. Okay, so you can, if this is selected on, you will not see any legend here. If it is selected off, you will see the off legend, and if it's faulty you will see the faulty legend. So just a quick note, you will not see both the legends at the same time. You will see only one legend, or if the system is operating in normal condition you will not see any of the legends in these push buttons. Right, next we have the cabin pressurization panel and we have the ventilation panel. So certain components which are related to the air conditioning system are controlled by these two panels. That's why these two panels are mentioned here. So when it comes to cabin pressurization panel, I told you that when we are selecting ram air, so we have to know the position of another push button which is located on the cabin pressure panel, that is the ditching push button. So here you will find the ditching push button. And if you can remember, I told you that we have two recirculation fans in the system, and for those fans here you get a push button, and in the ventilation panel, so in the ventilation panel you have the push button for recirculation fan, so which is shown to you by this cabin fan. So these, even though it says cabin fans, this switch will control the recirculation fans. Okay, now we'll go through the main switches and push buttons, and in the process I'll explain you, and I'll you the functions, and you might be able to recall the stuff from the last lessons as well. Okay, first of all we have the backflow selector here. So you can see that it has three positions: low, normal and high. So when the selector, you can place the flow selector in any of these positions. So if you place it in low position, you will get a flow corresponding to the 80% of the supply. So if you place it here in normal position, you will get 100% of flow, and if you place it in high, you get 120% of flow. So in case if you are using engine bleed instead of, in case if you are using APU bleed instead of engine bleed, in that case, even though you have placed this rotary selector in normal or low position, the supply will automatically shift to high demand. So whatever is selected by this rotary switch will not matter if you are using APU bleed supply for air conditioning system. In that case, automatically the flow will set to high value, which is 120% of the flow. Another thing, if you have only one pack in operation, again the same scenario, whatever the position of the rotary selector, you will get 120% of supply. And there's another thing, the third scenario, in case you have selected this to low. Why you select this to low? If you have less number of passengers in the cabin or the aircraft, so you can have this at low position, so you will get a low airflow into the cabin, therefore saving fuel. And when this is placed in low position, if the required cooling demand cannot be maintained or achieved, the system will give you the supply at 100%. So even though your rotary selector is at low, which corresponds to 80% of flow, and if the required or the demanded cooling amount cannot be achieved, the system will automatically shift to normal flow, which corresponds to 100% of flow. So if you are using APU bleed, or if you have only one pack operating, whatever the position of the rotary selector, you will get a flow at 120%. And if you have already placed this at low position and the required cooling amount cannot be maintained or achieved, the system will give you at a flow at 100%. So that is regarding this flow selector. And so what will be controlled by this rotary selector. If you can remember, I told you that the flow control valve has a torque motor to position it. So if you can remember, we talked about the flow control unit where you get the flow control valve, and there I told you that there's a torque motor which controls the position of the flow control valve. So when you place this rotary selector in whatever position, this signal will go to the air conditioning system control computer 1. So why it goes to 1? He is the one who is responsible for calculating the flow, required amount of flow. So the signal will go to the air conditioning system controller 1, and the air conditioning system control computer 1 will send a signal to the torque motor to position the flow control valve to the required amount of to the required position to give the necessary flow. So you move it, signal goes to the air conditioning system control computer 1, and if and the air conditioning system controller 1 will send the signal to its related flow control valve torque motor to the position the valve accordingly. Okay, so we will have the flow control or the pack flow selector valve if this is a A320 aircraft. In case if we have a A318 aircraft, so this pack flow selector switch will be replaced by this high flow push button. So what happens is, when you select it on, it will give high flow. In all other cases it will be modulating between, the flow control valve will be modulating between low and normal position. So you will not get this particular rotary switch in A318 aircraft. Instead of that, you will have this push button. And in A321 aircraft, again you will not have this selector valve. Instead of that, you will have this econ flow push button. Okay, so in this case, if you select on, if you switch it on, the valve can modulate between low and normal position, which is 80% to 100% position. So again this will also have that the three scenarios which we talked about. In case you are using APU bleed, you will get a high flow from the flow control valve. If only one pack is providing, same scenario, high flow. Okay, next we have 3 rotary selector switches, and you can also see that there are triangles at 12 o'clock positions, and each triangle directs to a box, right? So the first box says cockpit, second box forward cabin, third box you will see aft cabin written on it. So what this means is, I told you that the air conditioning system provides conditioned air to 3 zones in Airbus A320 aircraft. So these are the 3 zones. Last time also I told you the 3 zones are flight deck or cockpit, forward cabin and aft cabin. So that is what is shown here. Then the rotary selectors. So using these rotary selectors, you can set temperature. So you can set the required amount of temperature for each zone individually or independently. So now when you place this rotary switch in a particular place, so this zone will be provided that requested temperature based on the selection of the position of the rotary selector. So as I told you earlier, each zone can have their own temperature values. So to set those values, you can use these rotary selectors. And here you can see it says cold and here it says hot, so it is identical for all three rotary selectors. So if the rotary selector switch is at cold position, the temperature which is corresponding to the cold position would be 18 degrees Celsius, and if the rotary selector is set to hot position, the temperature corresponding to this hot position would be 30 degrees Celsius. So here at 12 o'clock you will have 24 degrees Celsius. So you can see that these lines you will have at 2 degree increments. So here it is 18 degrees, here you will have 20 degrees, here you will have 22 degrees, here it's 24, here it's 26, and here it's 28, and here it's 30. So it will be same for all three. So to simplify the thing, what will happen is, if for an example, if we say that we place the cockpit switch here which corresponds to 20 degrees, so the cockpit would be, the temperature at cockpit would be maintained at 20 degrees Celsius, and if we place the cabin switch here 24 degrees, forward cabin would be maintained at 24 degrees, and if we place it somewhere here, the aft cabin would be maintained at somewhere around 28 degrees. So that is the function of these rotary selector switches, and these signals, so the rotary selectors, the signals will go to the air conditioning system controller, and the temperature will be modulated based on these signals. Next we have these pack 1 and pack 2 push buttons. So you can see here it's you have two legends, you have the forward legend and the off legend, forward legend and the off legend, and if the aircraft is in normal operation, the packs are functioning fully, you will not see any legend on these push buttons, so it will be blank. So, and at the same time you will never see these two fault and off legends together. If you have a fault, you will only see the forward light. When you switch it off, you will see the off light, right? So what is this pack 1 push button and pack 2 push button? Okay, so this is used to switch on or off the flow control valve. Now if you can remember, in the last lesson we discussed about the flow control unit. There I told you that in the flow control unit there is a flow control valve, there is a torque motor, there are two pressure switches, there is one position sensor, and there are two solenoids. So this pack push button deals with one of those solenoids. So when it comes to pack air conditioning pack 1, so this particular switch will send the signal to its related solenoid. The pack number 2 will send the push button will send the signal to its related pack's flow control valve solenoid. So as I told you, in flow control unit we have two solenoids. Those two solenoids are, one is an on-off solenoid, other one is the mode solenoid. So this particular push button, the off function, so you can see that there is a fault legend and off legend. So the off function is directly connected to this. The signal from this push button directly goes to the flow control units, flow control valves on off solenoid. So when you select this off, the on-off solenoid on the flow control valve will get de-energized and the valve will close, right? And so that is, if it is pack 1 push button, when you select it off, pack 1 flow control valves on-off solenoid gets de-energized and the flow control valve of pack 1 will get closed. If it is the pack 2 push button, the flow control valves on-off solenoid of pack number 2 will get de-energized and the valve will close. The pneumatic backup mode solenoid or the mode solenoid will have nothing to do with this switch. And you can see that there's a fault indication here. So fault indication can come on based on certain failure conditions or warning conditions. In case there's a position disagreement between the flow control valve position and the cockpit selected switch, you will get this fault light. And at the same time, if you have compressor overheat condition, if you can remember, in last lesson I told you after the compressor there is a sensor which is known as compressor discharge temperature sensor, and there I told you that until 180 degrees of Celsius the system will operate in normal configuration, and when the temperature goes above 180 degrees until 220 degrees the flow control valve will continue to close, and if the temperature goes above 260 degrees, that is after the compressor, I told you if the aircraft is on ground you will get a fault light here, and at the same time the flow control valve will close, and if the aircraft is in flight you will get the fault light only, the valve will remain open, and you will get a compressor overheat ECAM warning as well. So in that case you will have this fault light. Next one, if you have high pack discharge temperatures, that is if you can remember, there was a temperature sensor after the condenser before the mix unit, which was the pack discharge temperature sensor. So the pack discharge temperature sensor is the one who gives the signal to the ECAM and this and that signal is also used to display the fault light along with pack overheat signal, and so you will get this fault light in case of compressor discharge overheat and pack overheat condition, plus during position disagreement. And when it comes to flow control valve push button, when it's selected on there won't be any indication, right? So and the flow control valve itself will have two closure modes. So one would be manual closure, the other one would be automatic closure. So what we discussed was the manual closure. That means you select it off with the push button, the flow control valves on-off solenoid will get de-energized and the valve will close. So now I told you that there is another closure mode which is an automatic closure mode. So what is automatic closure mode? In case if you have a engine start, so when you select and when you start the engines, the flow control valves will close. In this case both the flow control valves will close. So when the engine start is selected, the flow control valve will close, right? And there is another scenario which will close the flow control valve in case the ditching push button is selected on. So that means the ditching push button on cabin pressure panel is selected on, again both the flow control valves will close. The idea behind this function is, so in case if you have to ditch the aircraft, so when you press the ditching push button, all the valves and equipment below the waterline of the aircraft will get either valves will go to closed state or the components will get de-energized. So in that case the pack flow control valves will also close. In the same time, when you select the ditching on, the recirculation fans will also stop. And if you select the fire push button, so the related side pack flow control valve will close and you will get a fall light as well. So what that means is, if you select the engine 1 fire push button, the pack 1 flow control valve will close. If you select the fire push button of pack engine number 2, the pack 2 push button will close. So those are the functions of the pack push button. And there's another thing, so we call this as the pneumatic closure. In case all other parameters are okay, and if the upstream pressure, that is upstream pressure at the flow control valve itself, if it is less than the specific value, the flow control valve will remain closed. I told you that day it's an electrically controlled and pneumatically operated valve. So the electrical control function is via the solenoids, the pneumatic operation function is with the pneumatic pressure or the bleed pressure. If you don't have bleed pressure, even though you have a fully operational electrical system, the flow control valve will still remain closed. Right, next we have this hot air push button. So this push button is used to control the trim air pressure regulating valve. So if you can remember, it is controlled by air conditioning system control computer 1. So when you select this off, the air conditioning system controller 1 will get that signal and he will close the trim air pressure regulation valve via its motor. And in case if you have position disagreement, you will have this fall light. And at the same time, if you can remember, there were duct temperature sensors, and at least one duct detects a temperature above 88 degrees Celsius, the automatically the trim air pressure regulating valve will close, and with that all the trim air valves, that is quantity 3 if you don't have the optional cargo heating system, so all these trim air valves will also close, and this fall light will remain until that condition goes off. So what you can do is, when a duct detects a temperature about 88 degrees Celsius, so the trim air pressure regulation valve will close and you will get the fall light here. So you can switch it off and the fault legend will remain until the conditions are still available. So when the conditions goes off, you can switch it on and it will function in normal manner. And the next push button that we will discuss, which is located on the air conditioning panel, is this ram air push button. So this ram air push button, when you select it on, if this ditching is not selected, when the ram air push button is selected on, the ram air inlet will open. If you can remember, I told you that day, but the air flow will not come through the ram air inlet unless the differential pressure is less than 1 psi. So that flap is rated for 1 psi, right? So again when you select this on, if the ditching is not selected, ram air inlet will open, and when you descend below 10,000 feet and the differential pressure is less than 1 psi, the air will come in and the outflow valve will open to 50% if it is at the auto mode. So that means when you don't have this fall legend and on legend, so that is when the cabin pressure, the what you call the outflow valve in the cabin pressurization system is in auto mode. So just to remind you again, when the ram air push button is selected, ram air inlet will open if ditching is selected off, and when the differential pressure is less than 1 psi, the outflow valve will open to 50% if the outflow valve is in auto mode. Next, the other panel, the last panel which we have to discuss when it comes to air conditioning system cockpit controls, is this cabin fans. So this is in the ventilation panel. So if you can remember, I told you that there are recirculation fans. So the recirculation fans, there are two, and when you if you set this to off, both the recirculation fans will stop. So and you will get a fan indication on the SD as well. So we will look into that when we discuss the indications in the next lesson. So and there is another instance where you get the cabin fans to switch off, that is where the ditching is selected. So when the ditching is selected, the cabin fans will also stop. So basically these are the controls you will find in the Airbus A320 cockpit when it comes to air conditioning system. So just a quick summary, we have the pack flow control rotary switch here, and you have three positions: low, normal and high. Low corresponds to 80%, normal for 100% and high for 120%. In case if you have one pack in operation or you have APU bleed in use, whatever the position of the switch, the system will automatically move the flow control valve to supply 120% of flow. If you are using an A318 aircraft, you will have this push button, high flow push button, and if it is a 321 aircraft, you will have this econ flow. In those two aircrafts, you will not have this flow control selector valve. And then you have three zones: cockpit, forward and aft cabin, and you can set the temperature of each and every zone independently using these three rotary switches. So cold is corresponding to, so the cold means that when you place it here, you will get a temperature at 18 degrees. Here it's 30 degrees. Next we discuss about the pack push button. There I told you this controls the on off solenoid of the related flow control valve, and when you select it on, the flow control valve on off solenoid gets energized, and if you have upstream pressure, the flow control valve will open, and if you select it off, the valve will get de-energized. Then even though you have upstream pressure, the valve will not open. And when it comes to fault indication, I told you that this is mainly because of position disagreement, and when you have compressor overheat detection with pack overheat indication, then again you will have this fault light. And and at the same time when you have this pack overheat condition also, you will have this fall light. So compressor discharge temperature overheat, that is at 260 degrees, you will have this fall light. If the aircraft is on ground, in that case the flow control valve will also close, but in the aircraft is in air, the fall light you will get here, but the valve will not close. And I told you that there are three scenarios when it comes to when we have to discuss about the closure, that is manual closure, pneumatic closure, and automatic electrical closure. So manual closure is always via the push button, you set it off, the valve closes. Pneumatic closure, that is when you don't have enough upstream pressure. So this is electrically controlled, pneumatically operated valve, flow control valve. So when you don't have upstream pressure, the valve will not open. The last closure scenario we discussed was the automatic electrical closure. So in automatic electrical closure will happen if you have ditching selected, the valve will close, and in case you are trying to start the engines, the flow control valve will close. And if you have fire push button selected, the related side flow control valve will close. And in case you have compressor discharge overheat detected, again if the aircraft is on ground, the valve will close, right? So after that we discuss about this hot air push button. I told you that this is used to control the trim air pressure regulating valve, and you get this fault indication when duct temperatures read 88 degrees Celsius, and it will remain until that condition prevails. So to reset it, you can select it off and then select it on. The other push button we discussed in the air conditioning panel is this ram air push button. There I told you the ram, when you set this to on, and one thing I forgot to tell you, that it is guarded. So what you have to do is you will have to lift the guard, and then only you can press the switch. So guarded, so it is guarded to prevent inadvertent operation. So when you select it on, the ram air inlet will open, and when the aircraft descends below 10,000 feet and the differential pressure goes below 1 psi, if the mode selector is in auto position, you will have the ram air supply in the cabin. And the other push button we discussed was the cabin fans. So that is in the ventilation panel. So when you set this to off, the recirculation fans will stop, and there is another time which will there is another time where, so and there is another instance where the cabin fan, so the recirculation fan will get stopped. So that is when ditching is selected. So when you select the ditching on, all the valves and the equipment in the sense that fans and valves, isolation valves, so on and so forth, below the water line will get closed off to prevent water coming into the cabin in case of a ditching scenario. So basically those are the cockpit controls in Airbus A320 aircraft. So in the next lesson we'll have a look at the indications in the SD pages. So then you will have a complete understanding of the cockpit controls and indications of A320 aircraft. So until then, stay safe and fly safe.